Hi everyone. In this given problem statement, you have to solve maximum sum circular subarray. So this is an extension of Curdin's algorithm that we have solved earlier, but here we have to also take in count that the subarray or the array could be circular. So let us take this example, right? Here, right, the value, if we look into it in normal way, if I just apply Curdin's algorithm out here, then the maximum value that I can get, right, is going to be 5. But I am saying that this is a circular array, right? So the elements are like in a circular position, or let's say if I can draw a circle. So it's 5 minus 3 and 5, right? So here, right, this to 5 is going to make it 10. So this is a circular array. So here, right, if I have to break down the problem, right, so we are given an integer array nums and we need to find the maximum sum of a subarray. Considering this array is circular, the last element connects to the first. And also it's been given that the subarray must be contiguous, so we cannot skip any elements. So there could be two possible cases of maximum sum subarray. One is that it would be following a normal algorithm, right? So it could be a normal subarray. That means that maximum sum is obtained within the array. We can apply standard Curdin's algorithm. So let us take this example, right? Here it would be following a normal Curdin's algorithm, right? Here the maximum value would be 3. A case 2 can be that which could be a circular subarray, the maximum subarray sum wraps around the end of the array to the beginning of the array. If it's a circular subarray, right, or the maximum subarray wraps around, then the maximum sum is in the circular case can be obtained by excluding the minimum sum subarray. This is because removing the minimum subarray, the most negative part from the total sum leaves the maximum circular subarray. So here, right, we can just look into the problem statement and how we are going to do it. Let us take the example, right? We are going to apply normal Curdin's algorithm. So we know, right, normal Curdin's algorithm, let's say def Curdin. And here we am going to pass in the nums. And here, right, the maximum sum and our current sum is going to be the initial value. So it would be nums of 0. And now I can loop through. So for num in nums, here I've already taken the first element. So I will loop, means I've taken the 0th element. So I can loop from the first one. And now the important thing is that what would be the current sum? So current sum is going to be the maximum of the number, because in case it's negative, right, so we are going to start with a number, or I can add it with the current sum plus the maximum sum equal to the max of the current sum or the maximum sum. And after iterating through this loop, right, I'm going to get my maximum sum and I can return max sum. So here, right, so in the normal case, right, what I can do, right, so I can say max garden, and here I can just pass in the my current nums. And it is going to give me the result. So if I pass in this value, right, so in the max garden, right, I'm going to get the result. But there are also some edge cases that we need to look into, right? So here, right, let me take into the another situation. Let's say we have to also calculate some edge cases. So we also need to find the maximum subarray using Cardin's, but we also need to find the minimum sum subarray using Cardin's algorithm. So I can say minimum Cardin, and here, right, to find the minimum, what can I do, right? So I know the minimum would be -3 out here, but can I just change the equation a bit? Can I just pass the values like it to find the maximum value, or which would be a minimum in this case? So I'm going to say, and I'm going to pass in the Cardin, and here I'm going to pass minus num for num in nums. And if I do it right, so in this case, the maximum Cardin that I got is going to be 5 equal to 5. The minimum Cardin is going to be 3. And there would also be, so we have to return, right, total sum minus in normal cases, right? And there would be an edge cases, right? What if all the elements are negative? So in that case, how we're going to handle it? So in order for us to handle that, right, we can simply take the total sum, which is going to be sum of nums. And now I can say for this edge case, if total sum equal to minus of minimum of Cardin, in that case I can say return max of Cardin, else, or in the normal case, right, I can say return max of the maximum Cardin, or total sum plus minimum Cardin. So how it's going to work, right? Let us ignore this one for the time being. So the maximum Cardin that we got, right, is 5, minimum Cardin is 3, and the total of this one is going to be total would be minus, total would be 7. Okay, so here the max of Cardin, right, it would be, the return would be 5 or 7 plus 3. So our value would be 10 maximum. So this would be the output for this case. Alternative, right, in case all of them are negative, so my total sum is going to be -8. Okay, and the minimum current, right, all of them would be positive, so it will be also -8, right? So in that case I have to just return the max current. So here whatever element will be the lowest, right, so that would be our minimum subarray. So here the lowest is this -2, so the -2 would be our result. So I think this is a little bit tricky, how to manage this maximum sum circular array, which would be a modified cadence algorithm. But here, right, we have to keep a track of the maximum current, the minimum current. A minimum current is basically, right, we would just to reverse the parity of all the elements and find the value which would be the minimum, or you just have to add that to our cadence algorithm, get the total sum, and we have to just return the maximum current or the total sum plus minimum current. So that would be the output. So now let us jump to the Python solution, where we are going to understand or code this entire thing into more detail. The first thing that we need to do, right, we need to create our current function. So def current, and here I'm going to pass in the nums. So I'm going to get the maximum sum and the current sum equal to the first element, and then I'm going to loop through. So for num in nums, and I have to loop through the from first element because I've already taken the 0th element. So here, right, the current sum is going to be the maximum of num or current sum plus num, and the maximum sum is going to be the max of max sum or the current sum. And at last I need to return the max sum. Now let's say I have to get the maximum current. So I can simply call the function and pass in the nums. I also need to calculate the total one, so that in case it's a circular, right, so what would be the value. So I just can say sum of nums and the minimum current. So minimum, again I am going to call the function, but one thing is that, right, here I have to reverse the parity. So for example, 5 minus 3, 5 would become -5, 3 and 5. To get the minimum subarray within this, it would be num for num in nums. Now our thing is that in case we have to take an exception, so ideally you have to return the maximum of max current or total sum plus minimum current, and this should work except for one edge case that we need to check. Yeah, so I made one mistake. It would be I have to pass in both nums of 0. Let me run it now. Okay, so here, right, there is one edge case, right, in case all the numbers are negative. So what we need to do for that, how will I understand if all the numbers are negative, right? So to do that, if my total sum is equal to, so the minimum kitten is going to give the value in positive, so I have to get the minimum, so it would be minus of min current So in that case, I can say return the max. So that would basically return the value of the subarray in case the subarray contains all the negative one, right? So it is going to return the element with the least negative parity. So out here, right, -3, 2 and 3, right, it's going to return just 2. So that's the idea. Let me run it now. As you could see, all the public test cases passed. Let me submit the code. And as you could see, the code ran successfully. And if I look into the time complexity of it, right, it would be big O of n, or in better way, right, because we are calculating the cadence twice, it would be 3 big O of n, because in the first case, right, to get the maximum cadence we calculated once, then again for total sum we have to calculate this sum, and then again for the mean cadence. Although it is beating only 17.60, right, but it's still a pretty efficient solution. And I would suggest, right, there would be an other alternative, but which would be much more complex, and I just wanted to give you the most simpler solution to solve this problem. So that's all for this video. See you in the next one.